equation with two. I'm recording that. So if I said to you just that one on its own, solve it, what would be the problem? Yeah, there's an infinite number of values that x and y could possibly be. Remember I said, name a country, and tell me which one I'm thinking. Almost impossible, right? Same with this. There's an infinite number of x and y values that make that. How do I know there's an infinite? How can I see that? If you graph it. Yeah, if you graph it, there's a line, and the line that goes on forever, there's no gaps in it. Yeah, so that's how I can visualize that message, that there are an infinite number of x and y's. So if I want to know which x and y's I'm interested in, there's two unknowns, so I need two pieces of information that use the same x and y. So the second one that I've been given is 2x plus y equals 0. Right, so the second piece of information is 2x plus y equals 0. So this would actually be quite a nice one to do the substitution method. Why? This is 1y, so we could easily rearrange that, couldn't we? But we are using what method? Elimination. So remember, this first practice was the simple ones. You don't need to do an all. So what's the idea about elimination? So have we got that at the moment? X's. Oh, we've got the same amount of x's. Now, this is what I didn't mention yesterday, so pay attention to this point. This is, for me, is what makes it just obvious. If I take an x value and I double it, I get a number, right? I get an amount. That's what you would say. Think about it in English. If I take an x value and I double it, I get an answer. That's not the final answer. What do I then do? I take another number and triple it, times by 3, and I subtract that. And the result is negative 16. Now on the second equation, now I also double an x value, the same x value. And this time I add one lot of whatever y is, and I get a different answer. Now the reason why I need the same number of x's is because now it is quite clear that the change in this answer is caused by what? The y. Changing this bit here has changed the answer because the x bit's the same, right? That's kind of the principle behind this. Like, we are looking for the difference between the two, right? So by making one of the variables the same, I'm therefore going, well, the answer is different, therefore the one that is changed must have caused the change in the answer. Make sense? So what we're going to do with this one, well, this is a nice and simple one. Do you remember your elimination method? What do we do? Yeah, why do we subtract something? It gets rid of the x. When did we add? When there was a plus and a minus. Yeah, this time they're both positive x's, they're exactly the same. So if we subtract exactly the same thing, we get 0, right? So which one should I subtract? Now, remember I said it doesn't have to be 1 subtract 2. I am actually going to do number 2 subtract number 1. Why am I doing it that way around? Well, I'm actually subtracting a negative from a positive. So I'm actually going to have 2x subtract 2x is nothing, so I don't need to worry about that. Right, that's gone. That's the elimination done. In this block, I've got positive y subtract negative 3y. Positive 4y, isn't it? Because if you subtract a negative, it's the same thing as adding number. Yeah, y plus 3y. And then I've got the same thing here. Look, it's going to be 0 subtract negative 16, which is the same as 0 plus 16, which equals 16. Yeah. So at this stage, we've got 4y must equal 16, therefore y must equal 4. Okay. And I will do the next step, which is use y equals 4 in, which one should I go with? This one's easier. Number 2. Okay, so I've got 2x plus 4 now equals 0. What do I do? You have to, subtract 4 from each side. Leaves me with 2x's equals negative 4, which means 1x must equal negative 2. So I think that's my x value. I think that's my y value. Right, I used y that I found in equation number 2. All right. So how do I do my check?
Just put them back into either.
So I put them both back into number 1. Why number 1? Because I used number 2 to find the x value. So x and y, assuming I did this bit correctly, this will work in number 2. But it might not work in number 1 if I made a mistake finding y in the first place. How many answers for x and y are there for each one individually? Infinite. There are an infinite number of x and y's that work for each one individually. But how many x and y's work in both of them? Just one. So if I made a mistake with the y, I could have the correct x for number 2. But it might not work for number 1. So we should check. Now, whether you do this pen and paper or whether you do it mentally, because you're in an assessment, but you know, you're checking it. It'd be silly, really, to do all this work and not do a check and realize, oh, I got something wrong. So I'm just going to do my check. 2 times negative 2 minus 3 times 4 should equal negative 16. That's the question. I've got negative 4 minus 12 does equal negative 16. I am happy that those are the right answers. Right. Now that can be just done in your head if you want, but try and do it. You know, I guess one of the biggest frustrations for me in assessments when I you've come up with an answer that blatantly will not work in the first one, right? Now, you obviously in an assessment you have to make a decision. If you know it's wrong, well, you know you're going to get some credit for using an appropriate method, right? You've got to make a decision. Do I have enough time to go back and check everything and figure out where my mistake is, or am I running out of time? But if you know you're wrong, you know you're wrong. Rather than thinking you're right, get to the end of the test with 15 minutes spare. Spots, can I go get a book or toilet or something? Have you checked it? Yeah, I've checked it. Yeah, definitely checked it. Yes, Nico.
Wait, here's the question. How do you like do the check?
Well, I worked out what x and y have, what I think they're going to be. Yeah, you all right with that? And I've checked by putting this x and y into number 1. Yeah.
Did you have?
Everyone's said it because I know I've said this.
You did.
because like I said, a lot actually, if I use number 2, if in this first process, the first bit in red, if I do that and I do make a mistake, and I get the wrong value of y, for instance, which happens, it does happen, because that bit's the most complicated bit, right? If I get a number there and get it wrong, I can still go and find the next value by putting it in, and I would go, oh, I found y. Let's say I found y is 7, for whatever reason. Let's say what one of you did try and do, what is y minus 3? Minus 2. So minus 2y equals 16. What would I end up with? Yeah. Should we just do that? So just as an example, right? So a mistake, a common mistake, not a common mistake, a mistake in this sense would, what if I did this bit and I actually ended up with negative 2y equals 16 at this line, yeah? Number 2, subtract 1, and I end up with that. And you can see how that would happen, right? Yeah? Because y minus 3, people go, all right, 1 minus 3, minus 2. There's no real kind of, oh my God, that's such a stupid, that's a relevant, normal mistake to make, right? Yes. Need to. What would y become? Y would equal negative 8. Is that, would that throw you out in a test? No. No, what I mean is, would that in your mind go, I must have made a mistake, it's negative 8? No, wouldn't be. If I got negative 2.731498, I'd be like, something's wrong there, I don't tend to get that, I tend to get whole numbers. But if I got y equals negative 8, I'd be like, that makes sense, I'm happy with that. Right? What do we then do? We do what we've been, let's use y equals negative 8 this time. So use y equals negative 8 in number 2 again. Right? So 2x minus 8 equals 0. Plus 8. 2x equals 8. X equals 4. Perfect. All right. I've got y equals negative 8, x equals 4. Let's move on to perfectly reasonable answers. Do whole number answers. Absolutely no problem. Mr. Potts said I should always check my work. I don't need to, because I'm confident that those are right. But let's do it for that person. Let's check in which one?
1.
Okay, check in number 1. So number 1 is what again? So 2 times x minus 3 times y. So 2x minus 3y should equal negative 16. So let's put this in. So that's 2 times 4 minus 3 times negative 8. I made a mistake, but you know what I mean. So that's 8 minus 24 should equal negative 16. Perfect, I'm correct, because 8 minus 24 is negative 16. 8 minus 24 is negative 16. But it's not that though, is it? It's 8 minus 24, which is actually 8 plus 24, which is 32. So wrong, I'm unhappy. I know I've made a mistake, but the only time I would know if I've made a mistake is if I did the check. Because it doesn't work. This x and y was found by using number 2, right? Yeah? I used y equals negative 8 in number 2. I found that x has to be 4. Alright? That definitely is a pair that is in, it works for number 2. That line that number 2 is, it will have a 4 and negative 8 on it. But does number 1 have it? So if I put those same two numbers into number 1, they should equal negative 16. And they didn't. They equaled 32. So therefore, 4 and negative 8 are not. Now, if I just show you, visualize, just so you're aware of what that means. What that is if I've got two lines that cross like this, I'm looking for this point here, yeah? Now, what I found was that 4 and negative 8 work. So let's say this is number 1 and this is number 2. Let's say this point here is 4, negative 8. It will work in number 1. It won't work in number 2. All right? So what I'm looking for, if I make a mistake mathematically, I'll find a point. I'll find that point, let's say. No problem? And then I'll find that point using number 1, and it'll work for number 1. But if it doesn't work in number 2, it's not that point there.
If we did 1 minus 2 at the start, do we have to check them too?
No, that's not the. Basically, the 1 minus 2, 2 minus 1, that's not it. I've used that to find the first one. All right? That's always good. It's which equation do you use to find the second one? That's the important bit. So if I use y equals 4 in number 2, I then have to check in number 1. So it's the second and third one. All right. How do you feel? Should be making sense. All right. I'm going to ask you now to have a go at number 4, just quickly. Should be able to do number 4, and then we can rattle through it together very quickly and see what we can. What are you going to do with this one? Are you going to add it or subtract it? Why are we going to add? Because it's positive and negative. So when it's positive and negative, we're going to add. So I am recording now. So I've got these two. I've identified that 2 y's, that's the thing to try and eliminate. It was suggested if I wanted to, I could just focus on the x's and multiply the both, but we've already talked about the intention is to eliminate the y's. So because the signs are different, plus and minus, we are going to add them. So 1 plus 2, and yes, when you're adding, what order are you doing? 3x plus 5x is 8x. This is done. 11 plus 13 is 24. Therefore, x must equal 3. I'm going to use x equals 3 in, that's now, isn't it? So that's so bad. Use number 3 in 2. 5 times 3 minus 2 times y equals 13. So 15 minus 2y is 13. I'm going to plus the 2y minus 13. I end up with 2 equals 2y, which means y equals 1. Okay. I am then going to check x equals 3, y equals 1 in number 1. So 3 times 3 plus 2 times 1 should equal 11. I've got 9 plus 2. It does indeed equal 11. So I am happy. All right. So I said I was going to give you another option. So you're all happy. You've got that one written, right? That method? No, you've got your method written. You finished, right?
Yeah.
Okay, good. Unless you've got a question, which I'll come back to. Right. The other option is to do this. The signs are different. One way of changing the sign of any number is to multiply it by -1. So I am going to do -1 times this one. So number 1 is still 3x plus 2y is 11, but new number 2 is minus 5x plus 2y equals negative 13. Okay? Now, why did I do that? Well, now I can just subtract, and I'm going to do, doesn't really matter, let's just do 1 subtract 2, 3x subtract negative 5 is 8x, not negative, alright, 3x's subtract negative 5x is positive x. These go now, they're the same sign, so we can just subtract, equals 11 subtract negative 13 is 24 again. So I've got exactly the same answer at that point. Right? Now, you could say, well, why did we bother timesing by -1 if we get, it's just an extra step. Yes, it is. Right? But it is an option for those that want to do it. Right? All good? You can write that down off the video if you wish to. So let's move on to practice 4. Okay, I'll do number 1 with you. I don't know how much time we're going to have after that. Write down the notes. So we've got the first, you'll notice these are not labelled one time, you have to go to do it. So, number 1, 2x plus 5y equals 24. Feel free to write them 1 and 2 or 1 and 2, it's up to you, you don't have to write them that way around. Number 2, I'm going to write 4x plus 3y equals 20. So, what's the difference? We've already looked at one of these, this is where we started. Well, they're all positive, that makes it easier in some ways. The x's are different and the y's don't have one that's the same. All right, but we can do something about that. Which one should we focus on? Well, we wouldn't bother with the times by 1, we would just time the first one by 2. Why that?
So you can get it correct.
Yeah, because the new number 1 would become 4x plus 10y equals 24.
No.
Good. Definitely paying attention. 48. People forget. Even if they do it 1, they forget the other one. Number 2 is still 4x plus 3y equals 20. I don't need to tell you anymore, do I? Because it's exactly the same now as it was before. Go for it.